Hello there guys, welcome back to another epic and extra maths video. In this video we're looking at something called an improper integral, the idea of improper integrals. And in this case where infinity is a limit of integration. So we're looking at this question right here, the integral from 0 to infinity of e to the minus 2x with respect to x. The natural question is, what on earth, wait a second. Infinity? Infinity, how do I do that? Can I just plug infinity in when I integrate this? Like how does it work? What's going on? And also a very natural question is, shouldn't this just be equal to infinity? The area underneath the graph from 0 to infinity, surely it should just be infinity, right? But actually we find that in a lot of cases that's not the case. I'm going to explain everything. Don't worry, hold your horses guys. So let's begin by just drawing a picture of what we have here. So let's draw the function y equals e to the minus 2x, okay? So we get out our x and y axes, okay? Now the graph e to the minus 2x, you may not know how to draw it, and if you don't, that's okay. I'm just drawing it for the sake of demonstration. You don't necessarily need to draw it every time you do a question, although I probably would recommend it. But e to the minus 2x looks like this. So it's an exponential function, but it's reflected in the y-axis because it's e to the minus something times x. This point here is the point 1, because when x is 0, e to the minus 2 times 0 is e to the 0, which is 1. So it goes through 1. And again, yeah, this is the function y equals e to the minus 2x. Now, we want the area underneath this function between 0 and infinity, but let's just take a step back and let's work out the area between 0 and some number, maybe I'll call it t, okay? So between 0 and some value t, so maybe I'll say that t is about there. And what I'd like to do is find the area between these two values, okay? Now, why do I do that? Well, because we're breaking the problem down. Okay, and if we can come up with some sort of algebraic expression for this area here that I'm shading in, we can then just let t go to infinity using a limit, and then we'll be happy. So first of all, let's just write this down. So the integral in question is the integral, and we're just doing this at the moment, so the integral from 0 to t of e to the minus 2x with respect to x. And again, at the end of this question, we are going to be letting t go to infinity and then see what happens. So we should put a limit as t approaches infinity at the front of this. But we're not actually going to do anything with it until the end. Okay? So that's just going to be there. I know it looks maybe a little bit daunting, but it's just going to be there for now. And it's going to come along with us every single line. And it's really important, by the way, if you're doing something like A-level further maths, you've got to write this every single line, okay? Every single line. So let's just keep going. Again, we're just going to keep writing this limit as t approaches infinity, but we're not going to deal with it yet. I'm going to elaborate on it more later. Let's just do this. So just, for now, just focus on this integral. Okay, well, we can just do the integral, can't we? Because e to the minus 2x using the reverse chain rule, however you want to do it, you could do a u substitution if you really wanted. It would be minus 1/2 e to the minus 2x. And the limits are from 0 to t. Okay. Once again, writing the limit as t approaches infinity. Okay. Now, let's just plug in the limits, right? Let's just evaluate this integral in terms of t. So we're going to have minus 1/2 e to the minus 2t minus 1/2 e to the 2 times, or e to the minus 2 times 0. So just e to the 0 there. So we can simplify this ever so slightly. We have the limit as t approaches infinity of minus 1/2 e to the minus 2t, and then minus, that's going to be a plus. And we also have 1/2 e to the 0, but e to the 0 is the number 1, so plus 1/2. So just to be clear, what we have inside of these brackets currently is an algebraic expression for the area beneath the graph between 0 and some value t. And t could be whatever you want as long as it's positive. The area beneath this graph between 0 and t is this expression here. And we can see it depends on t. It's minus 1/2 e to the minus 2t plus 1/2. So if I change the value of t, if I let t be the number 1, if I let t be the number 2 or 3 or 4 or 5 or a decimal, then this is the area that I've shaded in, depending on whatever value of t you like. But we want t to go to infinity. So that's why we've been taking this limit, and that's what we're going to do now. So now we need to work out what this bracket is going to be equal to when we actually let t go to infinity. Now, maybe it's not too crazy, but this term here is going to end up being 0 as we let t go to infinity. Okay, I'm going to write this down. So minus 1/2 e to the minus 2t is going to approach 0 as t approaches infinity. Okay, and just to be clear, the reason for this is e to the minus 2t is the same as, this is the same as minus 1/2 times 1 over e to the 2t, right? And you can see that if we let t go to infinity, we're doing 1 divided by e to the power of a massive number. Well, that's going to go to 0 the bigger the number gets. It's going to go closer and closer to 0. The fact that we're timesing it by minus 1/2 has no relevance because we're just doing a minuscule, minuscule, minuscule number multiplied by minus 1/2. It's just still 0. So this is all 0, okay? Cool. So this becomes just 0 plus 1/2. So the answer is 1/2. And I guess I should put some equal signs in these. Becomes 1/2. So basically what I'm saying is, as t goes to infinity, the area that I've shaded in just gets closer and closer and closer to having an area of 1/2. And it will never go beyond that, even though it looks like it probably should, it actually won't, interestingly. Okay. And yeah, so I think that's it, guys. I will be doing many, many more videos on improper integrals. Rest assured, some of them are a little bit tricky, some of them are not too bad, but I'll go through each question slightly faster than the one I've just done here. I just wanted to make sure that everyone is fully clear on what we're doing, how we did it, and so and so. So thank you guys, as always, so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.